Hello. In this video, we're going to look at exponential functions. So the definition of an exponential function is that an exponential function takes the form f of x equals a to the x power, where a is greater than 0 and not equal to 1. So here's the thing. Since a has to be greater than 0, it starts here at 0 and goes to the right. Now it's a parentheses. But notice that we say that it can't equal 1 as well. So between 0 and 1, and then to the right of 1 is what we're looking at here. So we actually have several different things happening. Now, if a is greater than 1, then the function is increasing. An increasing exponential function is used to model cell division, compound interest, population growth, and other things. Now, if 0 is less than a is less than 1, in other words, if a is between 0 and 1 here, then the function is decreasing. Now notice that an exponential function will be a continuously increasing or continuously decreasing function. So a decreasing exponential function can be used to model radioactive decay, Newton's law of cooling, loss of memory over time, population for certain populations, for example, Japan, etc. The question becomes, how is an exponential function different from a power function such as y equals x squared? Okay, so here's the thing. Let's say y equals x squared is the polynomial function. What about the exponential function, 2 to the x? Well, look at the exponent. The exponent is part of the base for the polynomial. For the exponential, the variable is in the exponent, which is the reason we call this an exponential function. Okay, now we do have to be a little bit careful here. Not all bases can become an exponential function. Basically, the base has to be this a greater than 0 and not equal to 1. Okay, that's very important. So what I want to do is I want to go ahead and look at some properties of the graph by graphing the following on the same coordinate plane. So both of these will be exponential functions. For f of x here, we're going to have 2 to the x power. For g of x, we're going to have 1/2 to the x power. Okay. What I'm going to do is I'm going to try and look at f of x equals 2 to the x power, and I'm going to create a very large table for this function. Now, to do so, we need to figure out some x's to use. One thing that you're going to find out is that for exponential functions, the domain is all real numbers, negative infinity to infinity. So I'm going to use -3, -2, -1, 0, 1, 2, and 3. Excellent. Here's the thing though, the easiest one to look at is 0, because if you plug in 0 into this, you're going to get 2 to the 0 power, which is of course just 1. Now let's plug in the 1, which gives us 2 to the first power, which is 2. Plug in the 2, that gives us 2 squared, which is 4. Plug in the 3, that gives us 2 cubed, and that gives us 8. And the reason that that happens is that I'm taking this number and multiplying by whatever the base is. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, and so on and so forth. So if we wanted to look at the 4, it'd be 16, because 2 to the 4th power would be 16. And in other words, it would be 8 doubled, which is 16. Good. Now, let's go in the reverse direction to figure out these negative values. 2 to the -1, well, that negative exponent means that you flip the base, make the exponent positive, so it's just 1/2. For the next one, it's 2 to the -2, which is 1 over 2 squared, which is 1 over 4. Same thing for 2 to the -3. That gives us 1 over 8 whenever you simplify. But here's the thing. Notice that we're actually dividing by 2, or in other words, multiplying by a half when we're going to the left. In other words, we're multiplying by the reciprocal of the base when we're going to the left. So 1 times a half is a half times a half is a quarter times a half is an eighth. So basically we're just multiplying the denominator by whatever that is there. Good. And let's go ahead and graph this. -3, 1/8, -2, a quarter, -1, a half, 0, 1, 1, 2, 2, 4, 3, 8. And hopefully you're going to see what's happening there. Now notice that as x gets really, 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 really small, this is getting very close to 0 very fast going towards the left here. So when we try to connect this, when we try to connect this with a curve, it'll look something like that. Or as smooth as we can get. There we go. Good deal. So that right there is f of x. Next, I want to look at g of x being that 1/2 to the x power. Again, create an xy table there. And I'm going to use the same x's. And start out at the 0. 1/2 to the 0 power is just 1 because anything to the 0 power is 1. Now let's look at 1/2 to the first power. Well, that's just a half. 1/2 squared would be 1/4. Notice that what we're doing here is we're multiplying by the base. So 1 times a half is a half. 1/2 times a half is a quarter. 1/4 times a half is 1/8. In other words, 2 to the -3 power is what that is. And then go in the reverse direction. We're going to be dividing by a half. But the same thing as dividing by a half, what's the same thing as dividing by a half? Well, that's just multiplying by 2. And look at it this way. 1/2 to the -1 power, we take the reciprocal of the base, which is just 2, and say it's to the first power. And oh, look, that's just 2. Same thing with 1/2 to the -2 power. That gives me 2 squared, which is 4. 1/2 to the -3 power would give me 2 cubed, which is 8. In other words, we're multiplying by the reciprocal of the base, which is 2, when we go to the left in this case. Now, let's plot that. -3, positive 8, -2, positive 4, -1, 2, 0, 1, 1, 1/2, 2 1/4, 3 1/8. And notice that if we keep going towards the right here, it's going to basically start getting 0 going towards the right. And we are decreasing to the right. Good deal. So this is g of x. Awesome. But here's the thing. Because as the green function goes to the left, it goes towards 0, or as the blue function goes towards the right, it's going towards 0, that gives me a horizontal asymptote of y equals 0. That's very important. All exponential functions are going to have a horizontal asymptote of some sort. All right. I think it's a good idea to go ahead and end it here, and I will see you in the next video. Have fun.